Okay, next I want to cover some basics of the hydrologic cycle. The hydrologic cycle is about the movement of water. It evaporates over the ocean, it makes its way over land, and falls as precipitation. Precipitation can include rain, but also snow in places like the Sierra Nevada. And then eventually that water will kind of make its way back out into the ocean and completing the cycle. And it can make its way back in two ways. One is through surface runoff, through rivers and streams, and the other is through subsurface flow, through underground water. Here's a more California-specific example. We have evaporation in the ocean, clouds going over land, precipitation, a lot of that being snow in the Sierra Nevada, and the other part being rain. And this is showing some of the numbers. We get about 200 million acre feet. 1 acre foot is about enough water to cover a football field about a foot deep. About 200 million of those. We lose about 150 million of those through evapotranspiration, which is evaporation in plants losing water through their leaves. And then we have about 50 million acre feet of runoff, including about 20 million acre feet that are used by humans. The remainder of it goes through pretty much unobstructed through, as rivers kind of cycle their way back out into the ocean. So we use a good chunk of it before it makes its way out. So a more realistic view of the hydrologic cycle in California is including the human aspect of it as well. We have evaporation from the ocean, condensation from the clouds that falls as rain or snow. The snow stays in the Sierra Nevada for a longer period of time. The rain run off quite quickly. Those will go into streams and also flow and also soak into the ground. And then that water kind of makes its way eventually back out into the ocean. I want to also talk about a little bit about the distribution of water in the ocean versus land. So just big picture, on Earth, about the majority of the water, about 97% is in the ocean, and only about 3% is fresh water, water that's usable by people for irrigation or for human consumption. And if we look at where that fresh water is, the vast majority of it is in glaciers, particularly in Antarctica and Greenland, mostly in Antarctica. About 30% is in groundwater. So groundwater is a much larger source of fresh water on the earth than is surface water. Surface water, or atmospheric water, or soil water only makes up about 1% of fresh water on earth. And the reason we don't have that many glaciers, we used to in the Sierra Nevada, we have a little bit that remain now, but glaciers in other places, particularly Antarctica, can impact the water environment in California. And that is through sea level changes. So how much water is in glaciers impacts how much water is in the ocean. So sea level changes are caused by changes in ocean volume, how much water is in the ocean. So during ice ages, sea levels go down because there's more water locked up on the land. So this is a view of estimated view of the Central Valley of California during the ice ages, including a large amount of glacial ice in the Sierra Nevada and a lower sea level. So this is San Francisco Bay, and during the ice ages, sea levels were much lower and our coastline was farther off the coast. At one time, we had a large lake that developed because of the coast ranges rising and blocking off river flow from the Central Valley. This was called Lake Corcoran, and it was around for about 500,000 years during the ice ages. However, today sea levels are much different because as the climate has warmed up since the ice ages, sea levels have risen up into and created the San Francisco Bay and also the delta here just past there. So just some views of sea level change over time. About 3 to 4 million years ago, before the ice ages, the planet was much warmer And the coast ranges were also lower, and so we had actually more of an inland ocean in the southern Central Valley. Water would flow southward into this area of the ocean and through what's now kind of Paso Robles out to sea. And then as we got into the ice ages, we got much colder, and now the coastline is much further off the coast. And then we have the snowpack in the Sierra Nevada and the glacial ice in the Sierra Nevada. One other thing about during the ice ages is that in the desert areas, the inland areas, the transmontane areas of California, we also had larger freshwater lakes, and that was true throughout the basin and range area. And so there's a lot of dry lake beds in the Mojave Desert that are remnants of earlier freshwater lakes. As we go towards the end of the ice ages into the Holocene, about 10,000 years ago, as the ice ages ended, the ice in the Sierra Nevada starts to retreat. We now have water draining out of the valley through through rivers that ran through what's now San Francisco Bay. But we still had extensive wetland areas in the Central Valley, including this, which is Tulare Lake, a large freshwater lake, which is really a remnant of this larger Lake Corcoran that we had at one time. And as we move from the end of the ice ages to today, we have a rise in sea level filling up San Francisco Bay and up into the Delta. And we also have a lot of changes over the landscape because of the human modification of the environment. Now, one other thing to note about sea level is that sea levels also go up during times that are warmer. And so with a changing climate, a warming climate, and melting glaciers, one concern about in California is sea level rise in San Francisco Bay and this area called the Delta, which is a little bit further inland than San Francisco Bay.